Welcome back. To finish up multiplication, let's recall that not every radical expression has to be written with a radical symbol. We can also use a rational exponent, a fraction, to mean the same thing. So let's go to our PowerPoint and let's talk a minute about multiplying variables. Go back to basics. If I gave you a squared times a cubed, a monomial times a monomial, we know our product would be a monomial, and we know our rule of thumb is when you multiply variables, you add your exponents. So a squared times a cubed is a to the fifth. What happens now if the exponents were no longer whole numbers? What happens if they were fraction values? For example, if you look at the PowerPoint, a to the 1/2 times a to the 3/2. Well, guys and gals, the rule doesn't change. The rule is the rule. When you multiply variables, you add exponents. It doesn't mean the exponents have to be whole numbers. If the exponents are fractions, so be it, then add the fractions. But wait a minute. What have you learned about adding fractions? Ah, yes, you need a common denominator. So if we have the fraction 1/2 and 3/2, do we have a common denominator? Yes, we do. We have a 2. So how do we add fractions then? We write the bottom 2. We collect the top. 1 plus 3 is 4. So now your exponent is a to the 4/2. Is that acceptable 4/2? No, because 4/2 can be reduced to 2. So a to the 1/2 times a to the 3/2 is a squared. What I'm trying to show you is the rules don't change just because the expression looks different. The rule is the rule. Multiplying variables, you add exponents. If the exponents are whole numbers, you add them. If the exponents are fractions, you add them. Now, there is another way to work that expression. You could take a to the 1/2 and a to the 3/2 and rewrite it with a radical sign, a square root sign, and that would be fine. So let's just review that also. If I have the expression a to the 1/2, remember the numerator is still the exponent, so the exponent on a would be 1, and the denominator is the root, and root 2 is a square root. So a to the 1/2 really means the square root of a. A to the 3/2 means on the letter a, the exponent would be 3, and again the root would be a square root. So we would rewrite that as square root of a cubed. So now if I rewrite that from rational exponents to radical form with roots, I have square root of a times square root of a cubed, which I can multiply. I'd get square root of a to the 4th, and a to the 4th is a perfect square, and the square root of a to the 4th is a squared. So that's showing you, ladies and gentlemen, if I rewrote those rational exponents as roots, I would get the same answer. Now my question to you is, which way was quicker? Was it quicker to multiply leaving the expression with the rational exponents, or was it quicker to multiply by rewriting it in root radical form? Well, it's quicker to leave it as rational exponents, and that's what we do in algebra. If we have our expression with rational exponents, we leave it with the rational exponents. The reason why this module is in here, module 14, is because I need to make that connection with you guys that rational exponents are really roots. So if you did rewrite it, you would get the same result. Okay, let's try a couple on the whiteboard.